In order to multiply rational expressions, you have to realize that you're basically multiplying two fractions. And these fractions contain polynomials. And quite often, most of the time, these polynomials would need to be simplified, would actually need to be factored first before we can simplify. And if you look at the left fraction, 5a minus 5b divided by 10, the numerator, 5a minus 5b, we can take out a greatest common factor. That is the only way that we're going to be able to simplify that polynomial. So when we do that, the GCF is going to be a 5, because 5 is common in both of those terms. And anything that's not common stays inside the parentheses. So a minus b. And if you work backwards, if you take the 5 and then distribute with the a and the negative b, you're going to get 5a minus 5b. So it will check out. The GCF is going to be a 5. Okay? And the 10 stays the same. 2 stays the same. Now we look at the fraction to the right. You notice the denominator, a squared minus b squared. That is a difference of two perfect squares. So in order to simplify that, we're going to have to factor it. And again, simplifying perfect squares are easy because they have a very unique format. And the first term is a squared. Well, what times what is a squared? Is going to be a times a. A perfect square is something multiplied itself in order to give me that product. B squared, again, what times what is b squared? Well, it's going to be b times b. And then the signs have to be plus and minus. As long as one's positive and one is negative, it's going to work out fine. It does not matter the order of the signs in this case. So now we factored every polynomial possible, okay? And then the easy step now is to cancel. We want to cancel like factors before we multiply because it makes things simpler. And we do that, okay, I can cancel the a minus b because one factor is in the numerator, one's in the denominator. They are identical, including the signs, so we can cancel those. We can also cancel you can cancel the 5, okay? You can cancel the 5, and then you can cancel the 5 with the 10. 5 goes into 10 2 times, okay? And we can also cancel the 2's, okay? They're both divisible by 2, and those cancel. And then now we just write whatever's remaining, okay? So if you look at the numerator, everything canceled, but since nothing is remaining, we need to substitute a 1 there. There has to be something in place of that because we have a denominator of a plus b. So we want to make sure that we're writing it as 1 over a plus b and not just a plus b. So all of the terms in the numerator canceled, and then we're left with a plus b in the denominator. So we must write it as 1 over a plus b. And then that is your answer. That is as far as we can go, and that will be your final solution.